Welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Aryabhat College, University of Delhi. So as you all are aware that presently we are learning operating system concepts, and the current topic which we are going through is process synchronization, and we have seen what actually this process synchronization is, what is this problem, and then what are the various possible solutions for this problem of process synchronization. And since 2-3 lectures we are going through the classical problems of synchronization, and we have mentioned that there are 3 classical problems of synchronization. These are producer consumer problem, reader writer's problem, and dining philosopher's problem. Why these classical problems of synchronization known by this name? Because these are the problems on which any synchronization solution which is we can say discovered, that is going to be tested on these problems. And in this series we have also seen producer consumer problem, that what it is and what are the possible solutions for producer consumer problem. So with this background, let us begin today's lecture, which is about the second problem in the list of this classical problems of synchronization, and that is the reader's writer problem. So first of all, let us try to understand what is reader's writer problem. So let's say we have a account or a bank account, and so one process is trying to trying to read the balance of that particular account, and another process is trying to update, whether increase or decrease, but it is trying to update that particular balance of the account. So basically we have concurrent processes which are sharing a database, or maybe some data is being shared among several concurrent processes. This is a very common scenario, as I have told you, the scenario of account balance. Now these concurrent processes, when I am talking about, some of these processes may only want to read the database or may only want to read the data, whereas others may want to update, that is to read and write both. So what is the problem here? The problem says these the processes which are trying to read the data, if there are n number of processes which are trying simultaneously to read the data, no adverse effect is going to result. But if there are some processes which are trying to write something or which are trying to update something, so giving access of a particular data to the process which is trying to write or which is trying to update the amount, and that to some such processes, that means more than one, may be a problem, because everyone is going to update this thing. So basically these two types of processes are known as reader's process and the writer process. As the name indicates, reader process is something which is trying to read that piece of data, and writer process is something which is trying to also write that particular piece of data. So readers accessing the shared data simultaneously, that's perfectly fine, but some writers and also other processes, maybe readers also accessing the database simultaneously, there are going to bound to have some issues or chaos, we can say. So now what is the requirement here? By looking into this reader's writer problem, the requirement which we can define here is the writers must have exclusive access to the shared database while writing to the database, and no other process is allowed to intervene in between when any of the writer process is accessing that shared database. And this type of synchronization problem is referred to as reader's writer problem. So there are reader processes, there are writer processes, and a synchronization mechanism is required in order to have consistent data, or in order to have a chaos free process, we can say. So now basically this is the classical problem of synchronization, which is used to test every new synchronization solution or every new synchronization primitive which comes into the domain or which comes into the literature, that is being tested by using these classical problems of synchronization. One of them which we are studying today, that is readers writer problem. So till this point we have understand what is readers writer problem so far, but it is also having kind of, we can say, variations depending upon the priorities. So what could be the variations? So we may have first readers then writers problem, which is specifically known as first readers writers problem. This requires that no reader should be kept waiting unless a writer has already obtained permission to use the shared object. That means readers are going to be taken first or going to be accessed first unless the database or unless the data is already blocked by a writer. We cannot make any reader kind of kept waiting. Then the second one, or in continuation to this, we have the second readers writers problem. The first reader writer problem was that no reader should be kept waiting unless a writer has obtained permission to use the shared object. That essentially means no reader should wait for other readers to finish simply because a writer is waiting. So that's the thing, that means readers should not be kept in waiting. The second variation or the second flavor of this reader writer problem is second readers writers problem. This requires that once a writer is ready, the writer perform its write as soon as possible. If a writer is waiting to access the object, no new readers may start the reading. So earlier one was no reader should wait for other writers to finish, other readers to finish, simply because a writer is waiting, so readers can go simultaneously, readers will be given the first access. While in the second variation, which is of second readers writer problem, if a writer is waiting to access the object, no new readers may start the reading. So that's the two variation which says first readers writers, and another one is named as second readers writers. So that is basically depending upon, or the naming convention is depending upon where are you taking or where are you placing the reader process which is waiting to access to read the object. Now so for example, we are going to give a solution to either the problem. So in this solutions, what about the conditions which we try to, we can say, avoid? For example, we have starvation, we have deadlock. So a solution to either of these problems, first reader writers or the second readers writer problem, is going to result in an starvation scenario. Why? Because in the first case writers are starving because readers are getting access, and in the second case, as readers are given the second priority, the readers may starve. So if we are going to take these variations of the readers writer problem, either the first reader writer or the second reader writer, it is bound to result in a situation of starvation, or in a condition of starvation, we can say. In the first reader writer problem, as the readers are given the first access, writers may starve, while in the second case is just the opposite, vice versa, in which the readers may starve because readers are given the second priority. So with this, what is the solution to this readers writer problem and its various variations? So this solutions we are going to or solution is given here with the help of through the use of semaphores. And what is semaphore? We have already kind of seen that in kind of detail. This is kind of we can say a construct or a lock mechanism, we can say, which is going to lock various items which are in the shared access. So let us try to understand solution to both the variations of reader writer problem with the help of semaphore. So in first readers writers problem, the solution is to have some variables, two of which are semaphore and one is about the read count. So, in the solution to the first reader writer problem, the reader processes share the following data structures. Now, what data structures I am talking about here is two semaphores. One is RW mutex and another one is named as just mutex. So, RW here stands for read and write. Both these mutex have been kind of initialized as 1 and integer read count has been initialized as 0. So, semaphore RW mutex is a variable which is going to keep the track of the process which is reading writing, and this is kind of one if one process is reading and writing both, that means it is updating the data item, the shared data item, no other process will be allowed to access or no other process will be allowed to lock this semaphore RW mutex, and another one is the mutex which is not the RW mutex, that is going to be accessed by all the readers, and how many readers are accessing that count is going to be kind of taken up with the help of this integer read count. So, we have a semaphore mutex and RW mutex both initialized to 1 and the read count is initialized to 0, and the semaphore RW mutex, as I have already told you, is common to both readers and writers, while the semaphore mutex is only for we can say readers. Now, coming to the solution of this. So, what is happening here? What is that process, or which is that process which we want should not be kind of executed simultaneously. So, that is an RW process, that is a read write process, or that is an update process, in other words we can say. So, here we have already seen the utility of the wait and signal functions or the wait and signal system calls. So, one who is going to perform the writing is going to acquire that semaphores and semaphore which is RW. So, now in the loop of do while we are saying wait RW mutex, that means lock. Wait RW mutex essentially means that the lock has been acquired by a process, and the lock, which lock I am talking about here, it is the lock is the RW lock. So, RW is the update lock or the read write lock, that means no kind of I can say no other process is going to take this RW mutex unless the signal function call has been called, where the signal function call is there to we can say release the the mutex RW mutex which has been captured by using wait. So, we have given wait RW mutex and the writing is performed. It wait RW mutex has been kind of executed, no one else can perform the read write until after this wait writing process which is having this mutex is going to release this semaphore with the help of signal RW mutex, and this will keep on kind of going on till we have some processes. So, within the loop of do while true we have wait, then writing is performed and then signal, and this is being controlled with the help of RW mutex. As we have seen, this RW mutex is a semaphore which is initialized as value 1. But apart from that, this RW mutex we have already we have also taken up the mutex R mutex or the read mutex, and also we have read write read count also. So, not only this RW mutex can be used by the process which is performing the RW or the read write activity, it is also used by the first or last reader that enters or exit the critical section. If the first kind of reader process is entering the critical section, this is also going to use this RW mutex, and also the last reader that is exiting from the critical section will also use this. It is not going to be used by the readers who enter or exit while other readers are in their critical section. So, what I am trying to say here is only the readers which are entering into the critical section will be using this RW mutex. So with this establishment, if we can look, if we can have a look at the whole complete scenario of the performance of readers as well as writer process, we have a do while true loop which is saying wait mutex, and wait mutex is obviously, as I have told you, this is the mutex, not the RW mutex. That means this is going to be acquired by one of the reader processes. So we have incremented the read count, which is read count plus plus, and if read count equals to 1, then only we can have we can give someone else to acquire the RW mutex with the help of wait, and then here we can also release the signal mutex. So till we have count equals to 1, read count equals to 1 means we have at least one process or we have one process which is performing the reading. So wait RW mutex has been taken, that can be taken simultaneously, and signal mutex, that means the mutex normal mutex has been released, and then there we have the performance or the execution of this reading process, and then we have wait mutex. Again that mutex has been acquired by a reading process. Now as the reading has been performed, earlier we have we can say incremented the count, now we are going to decrement the read count, because now this reader process in a way is relinquishing the control of the mutex. So we have read count minus minus, and if read count equals to 0, that means no process is reading your data or the shared data at this point of time. We need to say signal RW mutex and signal mutex both, and this process will go on till we have processes which are requesting for the access. So let us try to see this again. We have wait mutex, and after this wait mutex, because this mutex has been taken up by some reader process, because only reading option if we are talking about mutex will help, and if we are talking about reading writing, then RW mutex is going to help us. So if wait is called on the mutex, that means read count has been incremented, one more process is reading, and if it is equals to 1, we have wait RW mutex and signal mutex both, then the reading is being performed. Then after that again wait on the mutex has been acquired, just for we need to decrement the count, because now one process is releasing this mutex, and if read count equals to 0, we are also releasing the mutex and the RW mutex both. So this is what the we can say process is when we talk about the solution to the readers writers problem. So we can also understand this by the fact that if a writer is in the critical section and n readers are waiting, then one reader can be taken on the RW mutex and other n-1 readers can be queued on the mutex only. And also we have seen that when a writer executes signal RW mutex, that means that mutex has been released, it is going to resume the execution of either the waiting readers or a single waiting writer. So whenever this RW mutex is going to be released, if we have others like one waiting writer or maybe other waiting readers which could be multiple in numbers, those will be given the access. And who is going to get the access? Is it going to be the writer or the single writer which is waiting, or it is going to be the multiple readers who are waiting for the data? That selection is going to be made by the scheduler only. So we have a scheduler here. And what do you mean by scheduler? That we have already seen when we have started this series of operating system concept. So this process which is going to kind of take that particular data, or which is going to access that particular data, that selection is made by the reader. Now here basically what we have done, we have acquired a reader writer lock which is requiring to specify the mode of index. So whether it is only read access or it is a read write access, and how we have controlled that? We have controlled that with the help of two semaphores, one is RW mutex and another one is mutex. So basically it is not about acquiring a lock, but also acquiring a lock and specifying the mode of the lock, that in which mode, either the read or read write, or simply we can say write, in which mode do you want. So when a process wishes only to read the shared data, it requests the reader writer lock in read mode, and on the contrary, if the process is wishing to modify the shared data, it must request the lock in the RW mode. And this is now very clear that multiple processes are permitted to concurrently acquire a reader writer lock in read mode, but if we talk about this lock in a writing mode, that means only one process is going to acquire this lock for writing, as exclusive access is required for the writer process. When the mutex semaphore is used to ensure the mutual exclusion, the variable read count is updated in order to keep a track of how many processes are counting, how many processes are reading the particular data. So read count is going to keep the track of how many processes are currently reading the object, and the semaphore RW mutex functions as a mutual exclusion semaphore for the writers, that we have seen. And we have also seen that if an RW mutex is acquired, only one reader acquired by a writer, only one reader can acquire RW mutex apart from this reader, apart from that writer, and other readers, if they are waiting, will be having the lock of the access of the mutex, not the RW mutex. So that was the basic fundamentals of this solution. So till this point in the lecture, what we have seen is we have started with classical problem of synchronization. After a quick recap, we have jumped on to the reader writer problem. We have understood what this reader writer problem is. Multiple processes trying to access the shared data, and there are readers as well as writers. Writers are the processes which are looking for the exclusive access, while readers can have access, simultaneous access also, because of the nature of the operation which they want to perform in that particular data. Now how semaphores are going to solve this synchronization problem? So two semaphores, one is mutex and another one is RW mutex. RW mutex can be given only to one writer plus one reader can be given, while other can be given only the mutex, not the RW mutex. So that was the solution, and also a read count is keeping a check on how many number of readers are presently reading this the data which is being shared. So this was the solution which we have seen till this point. Also we need to have a look on what is the utility of this readers writers locks, or in what kind of applications we need to take up this solutions. So in the applications where it is clear, we have a clear demarcation of which processes need only the shared data and which processes need the shared data in exclusive write mode and which processes need them in the read mode. That separation has to be very, very clear. Or we have the applications in which we have more readers than the writers. That application also can use this solution, because the reader writer locks generally require more overhead to be established, then semaphore or mutual exclusion locks. So, this this is a kind of, we can say, a cheaper or a simpler idea to implement. Also, the increased concurrency of allowing multiple readers compensate for the overhead involved in setting up the reader writer lock. So, if we have more readers and we have a clear demarcation of which processes wants the read shared data and which processes are looking for write shared data, if we have these situations in mind, then definitely we can go for this reader writers locks. That is all from my side for this lecture. Here is a list of references which is being used for the preparation of the lecture. Hope you had enjoyed it. Thank you for a patient hearing.